This is 11.5. We're jumping into the questions now, actual questions. So let's get started. Number 1. For number 1 and 2, evaluate the ordinary annuity formula given M, R, and T respectively. Assume monthly payments. So that means N is equal to 12 in other words. Alright, so let's get started. Telling us the numbers in order. So the first number they're telling us is the M value. That means you're depositing $50 per interval. 5% is our interest rate, so as a decimal at 0.05. Okay, and we say is 12 because it says assume monthly payments. So that means 12 times in 1 year, and then this is for 3 years. All right, so these are my variables, right? And I'm just gonna look at this, focus on this formula. I want to know how much I'm going to end up with. So it says evaluate the annuity. In other words, how much money do you end up with at the end of 3 years, making $50 payments at 5% interest. You're paying every month, yeah? Okay, let's see. It's 50 times, I'm going to set 2 parentheses, one for the numerator and then one for this 1 plus R over N. To the in parentheses, N times T. Okay, let's start filling our actual numbers. So R was 0.05 and N was 12. And so here N is 12 again times 3. All right, and then minus 1, and then I can close off the numerator. And then I divide by the denominator, in parentheses again, R, which is 0.05 divided by 12. All right, you notice it looks slightly different from the format here. That's just because I included my 50 in the top, but if you multiply 50 on the side or the top, you notice I get the same number, right? 1937 on the side. If I put it on the top, it's the same thing because those are equivalent. But just for the heck of it, let's put it on the left to make it match this guy. All right, so what do I get? I get $1,937.67 to the nearest cent. Let's see, what did it ask us to round to? Was it nearest cents or dollars? Let's check. Oh, it actually didn't say. So since it didn't say, let's just assume cents. Okay, we'll go to the nearest cent. 1937.67. All right, this is not a question, but I would like to ask this follow-up question like on an exam, for example. So another question is, how much did you deposit and how much was interest that was earned? So how much did I deposit first? Let's see. I made $50 payments, right? And this was, let's do it this way. $50 payments, 12 times a year for 3 years. So 50 times 12 times 3, right? That's how much I actually deposited myself. 50 times 12 times 3, which is 1,800. Okay, so 1,800 for the course of 3 years was deposited, and how much was interest? Interest was 19, the value that I ended up with, right? 1937.67 minus that 1,800 that I deposited. So in other words, $137.67 was the interest amount. So 1,800 was deposited total, and then 137.67 was his gain in interest. Now that doesn't sound like too much, right? But it's only for 3 years. So as time progresses, this proportion is gonna also gonna increase. And I'll show you guys the graphs after we finish these questions. Let's do 2, and then I'll show you the graph. All right, so number 2, again $50. This time 5% at 30 years. All right, let's see. So $50, 5% again, N is 12. This time we're just changing 2 to 30. So let's see how that affects things. And shucks, I should have just left my formula in there because everything's pretty much the same. But oh well, no big deal. This is gonna be. Let's type it this way. A is equal to 50. Let's do a bracket here. 50 times 1 plus R is 0.05 divided by 12 raised to the NT, 12 times 30 this time, and then subtract 1. Oops. Oh, come on. Get to the right spot. Okay, subtract 1, and then divide by 0.05 over 12. This is the formula, yeah? Okay, how do you plug that into the calculator? Same way as before. It's 50 two parentheses, one for the numerator and one for this inside 1 plus 0.05 divided by 12. Raised to the, in parentheses, 12 times 30. Close off that parentheses, minus 1, and then close the top for the numerator, divide by, in parentheses, 0.05 divided by 12. Okay, what do I get? 41,612. So that's 41,612, and let's round to the nearest cent again, 93 cents. Okay, so the follow-up question I want to know too again, just like before, how much did I actually deposit and how much was interest? So let's see. I deposited $50, right? 12 times per year and for 30 years. So in other words, I deposited a total of $18,000 over the course of the 30 years. $18,000. All right. So how much of that was interest then? 41,612.93 minus 18,000. That means, oh, what did I do? Oh, there's no comma here. That means 23,612.93 cents was earned in interest. And there it is. Okay, that's number 2. Let's take a look at the graph. This time I'm going to go to desmos.com instead of the scientific calculator, and I'm going to click on Start Graphing. All right, let's start with A. Let's type the formula. A is equal to M. Let's do it the way that they have it written. 1 plus R over N to the NT minus 1 close parentheses divided by R over N. And close the bracket. Okay, so here's the formula. Wait, what did I type wrong? Oh, I don't know if it doesn't like the brackets, so I gotta use parentheses for some reason. Okay, I'm gonna add sliders for these. Actually, no, I'm not gonna add sliders. Let me just pick numbers. Let's say M is $1 for now. N is gonna be 12 because we're assuming monthly. And then R is gonna be a rate. Let's say let's do 0.05 again. Okay. Let's see what the graph looks like. Did I enter this correctly? Let's see. Okay, so the axis in the bottom is representing the number of years, yeah? All right, it's kind of hard to see because my scale is off. So to adjust my scale, things are going too quickly for me to get a good picture. So I'm gonna change my y-axis scale and say, let's take it to like 10,000, maybe 100,000, let's see. Okay, so here's a picture of what it looks like over time. Kind of similar to like what we saw with the compound interest formula, right? It has this sort of slow start and then it gets super steep as time progresses. It takes a little longer though, I think, than the compound interest because you don't start with the whole sum from the beginning. You're just sort of adding on slowly. But like realistically, right, if you're trying to save up, you're not necessarily going to have all that money to start with, so you make periodic payments instead. All right, let's see. Let me actually scale this back a little bit. Let's go back to 10,000, like where it was. This is just adjusting the scale of my graph. You can do that by clicking on this wrench here, and you see where you're at. Okay, so here at 10 years, I'm at $155. This is depositing $1 per month. Yeah. I should write another equation so we can compare how much I'm actually depositing. So let's say, how much am I actually depositing? Let's say we'll call that P. No, let's call it B for no particular reason. Okay. So B is the amount I'm depositing in actuality. So this would be like whatever my M value is times 12 times T. Yeah, this is how much times years, right? 12 times per year, or I should just say n times per year for T years, right? So you look at the difference. The black line represents how much I actually physically deposit, and the red line represents how much I end up with in the end, applying this interest. Now let's see what happens if R increases, the interest rate increases. So as the interest rate increases, what you expect happens, right? That thing steepens quicker. In fact, it looks like the difference from, oh, I'm sorry, that was like, this is a really high interest rate, that's why. Let me do 0 to, let's say 10%. Or let's go 15%. 0.01, so steps of 1%. So at 5% was where we're at, right? That's kind of how the graph looks like. If we increase to 7%, well, that looks nicer. Now I increase faster. At 10%, it just happens faster and faster, yeah. That thing gets steeper quicker and quicker. Okay, that's all. That's a picture of what's going on. Let's see. Should I stop? Let's just jam through all the questions. Let's see if we can just jam through all of them. I don't think it's going to take us that long. Okay, I'm going to go back to the calculator now. So calculator, decimals, scientific calculator. And forget the graph. Yes, farewell. All right, guys, let's do the rest. So now we're on to number 3. Find the value of the annuity. So this is the same type of question as before. Same type of question. In fact, I'm just going to jump straight into it. Oh, no, you know what? Let me just adjust this real quick so we can see what's happening. M is $100 this time instead of 50. The rate now is, 4%. Oh, man, junk. N is 12 still because it's monthly, and time is 5. Now, N sometimes it's not monthly. Sometimes if it's like quarterly, this would be 4. If it's yearly, it would be 1. If it's semi-annually, it would be 2, for example. And that means also that's the number of times you're depositing per year. Number of times depositing and the number of times compounding, same thing. Because we're talking about simple annuities, yeah. All right, let's plug this thing in. I'm not going to bother with this. Let's just take these values up here, and we're going to stick it into the calculator following this formula. So it's 100, that's the M. Let me just focus in on this thing. Bring it a little bigger. That's the M, right? And then I have 2 sets of parentheses, one for the outside, one for numerator, one for this top part, 1 plus R of N. So 1 plus 0.04 over 12. Raise that to the, in parentheses, 12 times 5. And then get back to the bottom, subtract 1. Divide that by, in parentheses, 0.04 over 12. Okay, and you get 6,629. So the time period is only 5 years, which is why this value is not so huge. Yeah. And let's just do the usual check. How much was actually deposited? 100 times 12 times 5. So 6,000 was actually deposited. That means $629, and looks like 90 cents to the nearest cent would be earned in interest. But to answer the question was, how much do you end up with, right? It says evaluate or find the value of the annuity. The value is just the total. So that would be that first number, 6,629 and 89.7 to the nearest cent, that would be 90 cents. So 90 cents. When you guys answer the question, just pay attention to what they ask you to round to. Sometimes it might be dollars, sometimes it might be cents, sometimes it might be something else. All right. Now the remaining 3 questions, let's see, this one is asking for the periodic payment. In other words, you want to know what M is. Number 5 is same thing. They want to know what M is. And the last one is a future value question. But let's take a quick break here, break the videos up. So this one is for numbers 1, 2, and 3. And then after that, we'll do the 4, 5, and 6 in the next one.